Okay, so first, the templates can go on functions or classes. So templates, when they go on functions, they are called function templates. So what is a function template? So function template represents really a family of functions. So it's not one function, it represents a family. Okay, that's the first thing that you have to understand. So it specifies essentially a pattern from which actual functions can be generated. How is it generated? By substituting what is called template arguments for template parameters. Okay. So first thing that you're noticing is that a template is actually not a function. So don't confuse a template as a function. So what is the typical syntax when it's applied to a function? So we can say template and then angle bracket, type name, capital T. Okay. So here that is followed by this T. So important thing to notice here that this is not a reserved symbol, not a reserved keyword. Okay, this you can choose anything. You can choose Y, Z, whatever you want. You can choose to represent with a word also. Okay, but this is a very common notation to use it as a T. Okay, so template type name T, and then this T is essentially represented by this T. So which means that this T can be any type effectively. So this, suppose I write T max, and then here I write const T ampersand X const T ampersand Y, and I write a max function that if X is less than Y, then return Y, else return X, right? So in this case, you can see I have written a template, but this template is not just one function, but it's a family of functions where this T can be replaced with an int, in which case it's going to serve the interest of int. If it is replaced with a float, it will serve the interest of float, right? Now, another very important point is that this definition must be defined in a header file. Okay, if you want it to be used by multiple source files. Okay, so let's take an example how it is going to be used. So int main, so suppose in the main function, now you want to use max. So max we want to do between, let's say, two integers 3 and 4. Okay, so this is what you are used to writing, right? You are used to writing the function name followed by the arguments, but here you have to specialize which type are you referring to. Therefore you have to put in the angle bracket what is going to replace this T. So in this case you are dealing with integer, so you replace with int. And as soon as you put int, this is going to then generate a function with t substituted by int. And that's what we said, that the function will be generated by the compiler, okay, by substituting the template arguments for the template parameters. So these are the template parameters. So this is called a template parameter. Template parameter. And this is what is called template argument. So you replace the template argument in the positions wherever the template parameter is going, and you get a new function generated. That's all. The idea is very simple. And likewise, if you have to compare now 5.6 and 6.8, right? So then you want to specialize with the template argument float as opposed to int. So you can immediately see the advantage of this. The advantage of this is that you don't have to write 10 different functions, 10 different max functions when you have 10 different utilization of the based on the different types that you have got. But you're only writing one template function or one function template, and based on which all the others will be automatically generated. Okay. Now, of course, you can have multiple template parameters. You can easily specify something like this: template, and then you can write down type name t1, comma type name t2, and like that, right? You can have more than one template parameters come through. Okay. All right, so that's hopefully clear. Now let's just quickly look into how non-type template parameter would look like. So non-type template parameter would look like template here is referring to int n, where you're doing void foo, and here you are saying int array of n elements. Okay. So in this case, the n is not a type here. N is the integer itself. Okay. So when you are calling this function, you can pass in the max value directly, and that will automatically generate the function for you at the compile time. Okay. I hope that is clear. So now if you want to combine the two, it would look like this. Okay. Template type name t, comma, this is non-type, so t value. Okay. We are here combining. You can see that whatever the type is, you're using the value here. So t max const t ampersand x. Okay. And here you want to return whether x is less than value, this value. Okay. And you ask, so in other words, this is a compile time known value. That's why you are allowing for this. So if so, then you return value, otherwise you return x, right? And last but not the least, there is class template. So we talked about function template, we talked about non-type template parameter, and now we are talking about the class template. So here, the idea is exactly the same. So a construct that represents a family of classes as opposed to a single class. Okay, so it specifies a pattern from which actual classes can be generated, and these are called parameterized classes, right? Because you're acting as a template parameter. So exactly like the function template, here the definition looks exactly the same: template and then angle bracket, type name t, okay? And then that is followed by, instead of function, it is followed by class. Class, and then whatever class name you have, okay? You can put this, if you like, that this carries inside the comment, that this essentially is of this, wherever you see t, it would be substituted by whatever the type name is passed through. And then you carry the definition of the class, okay? And then when you have to define the functions outside of the class, you will be defining like this. You have to write everywhere. So template type name t, and then you have to write a, and then angle bracket t, okay? And then colon colon. The extra thing that you are putting in is this angle bracket t, okay? And then followed by a, then const t ampersand a value. This is like a non-default constructor, which is kind of dependent on this t, yeah? So that you can write this function. So inside the class, you could have in the private section a value, so m val, some member value, which is of type t. So when you are instantiating the class, right, you can instantiate by, now this time when you have to instantiate, remember, previously we were just writing AA, right? But here, because we have a template parameter, therefore you need to have a template argument. So you have to say a int, right? So the moment you put a int, that means wherever there is t, that gets substituted with int. So this will get substituted with int. So you're able to generalize your class in this way. So far, one biggest example we can think of, because we have gone through writing so many classes so far, like we have written array class, we have written matrix class, we have written the linked list class. But you can imagine the linked list items can be of different kinds. It can be sometimes integer, sometimes float. So how do you generalize the linked list? So you have already written all these methods. You don't want to just copy paste the entire class that you have written for different types. You want it to be flexibly utilizable for any type of elements, right? So now in order to extend that, all you have to do is just add this template type name t to the top, and then substitute the, the, the linked list item type with t. Then your class is now available for any kind of types of elements, or any kind of types of items can be utilized there. So I hope this introduction makes sense. And I think once you get your hands dirty through this lab, it will become very clear, and you can also go over the notes. You can hear the recording again. So thank you very much.